Hello everyone, welcome to today's Novedge webinar, RailClone, Parametric Modeling Made Easy. This session will explain how RailClone's artist-friendly approach to parametric modeling can help you to model sophisticated procedural objects and fast. I just want to say that by the end of this webinar, you'll be able to create your own railings, balustrades, facades, floor seating, brise, soleils, ceilings, stairs, roads, bridges, and much more in a very simple way. And, with just using RailClone's easy to understand rule-based 1D and 2D arrays. And today's webinar presenter, Paul Roberts, joined i2 Software in 2013 as a training manager. He's an experienced 3D environment artist and educator who has been working with 3ds Max for over 15 years and as a 3D designer and lecturer for the games, product design, and visualization industries. Let me tell you a little bit about Novedge. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions that cater to virtually every designer's needs. So not just RailClone, but 3ds Max, you name it. Come visit us at novedge.com. And you can also find us on Facebook, Twitter, Instagram, you name it. On our next webinar, Cyborg 3D Mesh to CAD. And don't forget, we're recording today's webinar and you can watch it over and over again on our YouTube and Vimeo channels. And now I will share Paul's screen. Just give me a second to transition. Take it away, Paul.
Okay, hello. Yes, thank you for the introduction. I'm not sure how spooky it's going to be. I'm sorry about that, but I'll try my best. Yeah, so I'm Paul from i2 Software. Most of you will know us from ForestPack probably, but we have the second plugin, RailClone, which is increasingly popular too, and that's the subject of this particular webinar. So we're not going to look at ForestPack at all this time, just purely RailClone. So RailClone, as you just heard, is a parametric modeling tool. It's the idea of RailClone, the idea behind creating RailClone was to make a procedural modeling tool that was really accessible for artists. There are other procedural tools in other programs, but they're somewhat more akin to some kind of visual programming, and RailClone is array-based, so it should be easier to understand. And what I hope to do today is to go over some of those fundamentals. So often with presentations, we'll take a very fancy project, something quite showy, and illustrate how that's done with RailClone. But if you're new to RailClone, that can be an intimidating introduction to the plugin. So instead, in this particular hour we have together, instead of going through something advanced and sophisticated, what I'd like to do is to go over the absolute fundamentals to help users to get up and running with RailClone and to understand what's going on behind the scenes, the way that RailClone thinks and works, so that you can, instead of learning one application, take away your understanding and knowledge of RailClone and make your own new styles. As we've mentioned, please ask me questions throughout this. So feel free to interrupt with relevant questions, relevant to what we're talking about at the moment, but I'll happily answer them as we go, as opposed to waiting until the very, very end. And because I'm going to do this live, I should be able to react and make anything clearer that's not clear, or extend any point that you feel like you'd need extending. So here we go. So I'm actually going to start straight in 3ds Max and just hide this panel. Okay, here we go. So here we have 3ds Max. Now, most people's first introduction to RailClone will be to use something from our built-in library. And so you access this by clicking on the RailClone Pro button here and just dragging the gizmo out into the viewport. Come over to Modify and just pop open the library by clicking on this None button here. And you have a pretty extensive library with lots and lots of different styles that are just ready to use. So we've got various fences, for example. We've got guttering that you can apply to your buildings, various railing styles. We've got a whole load of relatively new roofing styles, different tiles and that kind of thing. We've got interior styles, escalators that I know are quite popular with people. flooring. If you haven't got floor generator or you want an alternative, different pattern that floor generator can't do. More railings. We've got roads in here, fences, shelving, all kinds of stuff. And really the best way, if you're completely new to RailClone, is to explore all of these and see how they're made. We're going to start with a very simple facade this time that's driven by a single spline. So I'm going to come into my facade category and go to curtain wall, and I'm just going to pick one of these here, curtain wall curve 01, and hit import selected. So that loads up the style, including the material, and it shows you a little preview here so you can see what you've got loaded. So the first thing you need to do when you've got a new style loaded is tell it the path it should use to create the geometry. And you do that by coming into the base objects rollout just here and picking a spline from the scene. And there you go, there's your facade on that spline. And if I pick the line, you can see this whole thing's fully parametric. I can move this around and change the path, and everything deforms accordingly. So that's nice and easy. Some styles will also have settings in here that you can adjust in the parameters rollout, but we'll come to this later. This one doesn't actually, so there's nothing we can adjust. All it does is follow the spline and deform the geometry. No big deal. So the first thing people normally want to do after that is they'll want to edit the geometry that's already in the style. Say this wall is okay, but the actual height between the floors on your building is actually a little bit higher than this. How do you make this a little bit taller? Well, the way you do that is you can get the geometry out of this RailClone object and then edit it. So you'd come back into the style editor, and this is like the brain of RailClone, if you like. This is how you create all your styles and your new parametric objects. And you open it by clicking on this little button here, Open Style Editor. And it brings up this node-based editor here. Now we'll talk more about what these things specifically mean in a minute, but basically what we've got here is little pieces of geometry. These are called segments. And they're little pieces of geometry that are distributed along this spline using rules which are created by this generator. And then here we have a path, which is the spline that's being used to drive the direction of the wall. But at the moment, if we click on these, there's no actual geometry for us to edit because these are embedded. And you see, if I click here and come over to the left here where it says object, this is where you'd normally pick the geometry from the scene, it says embedded. And that's because RailClone, unlike ForestPack, doesn't need the geometry to remain in the scene. You can delete it, and RailClone stores a copy internally. You can also get this back out of RailClone, so you can edit it. So to do that, you've got two ways of doing it. You can come here and go to extract segment to a new object, and you'd need to do this for each individual one. Or you can come up to the segments drop-down, and you can go to extract all. And it will say these have been created in the scene. And there they are. There's the segments that are inside this RailClone object. The nice thing about that now is this is a live link between the two. So what I can do is I can easily say add an edit poly modifier to the top of these. And then I could make it taller by just grabbing the vertices on top, and just scaling them up to change the height. So I've just taken an existing library style and modified it. So that's usually the first step for people learning RailClone. They'll usually take libraries and they'll start modifying the geometry that's already in them. The second thing you might want to do is use these as a basis for creating your own styles. So you're not really creating it from scratch. You're looking for something in the library that's similar, and instead of extracting the geometry, we're just going to replace it. And you can do that by just going into these segments here and picking one of these, where it says object here, and selecting something from the scene to replace it. So this is going to rely a little bit on an understanding of what these inputs mean. And what we'll do is we'll just start at the beginning of the spline and jump around a little bit so we can see how this all builds up. So you can see these have got names: default, start, corner, evenly, and end. Start here, if I add some geometry to that, this one here, you'll see it placed it at the start of the spline. That's what that input does, puts one piece of geometry at the beginning of the spline. And then you can guess the end would do the opposite and put something at the end of the spline. You've also got something called an evenly input. And these are these sort of poles you can see here. These are evenly distributed along the length of the spline. So I can pick a kind of joint here, click on that, and that puts them evenly along the spline. This value is adjusted by going into the generator to the rules tab and changing the evenly distance here, which we'll talk more about later. So then finally, there's only one segment left to replace, which is the default segment. And what default does is it fills in between all the other segments. So it fills in between the start, corner, evenly, and end, these gaps here, basically. So you can just click this to pick what is basically a little slice of glass and facade here, and it will fill in between. And there you go. So now we've taken that library style and completely replaced it with our own geometry to create something completely different. Good. So the next step after you've started to adapt styles like this is to start to understand the rules in order to be able to create your own. And so in order to do that, I'm going to open a different file. I'm going to open this one here. So this style here is going to be used to create a facade all around this kind of strange looking building. Again, the geometry here is all simplified for demonstration purposes. What I've got is a series of ground plates, floor plates, sorry, and around the base of each one, I've got a spline. A few other things to mention about this spline. On the corners, just for the purpose of demonstrating something in a second, I've got a spline ID or material ID of 2. And for everything else, a material ID of 1. So that will allow me to identify the corners separately in RailClone and put different geometry in just those areas if I choose to. I've also got some slices of facade here that I'm going to use. So this one will be the start and the end. This one here is going to be the evenly. I've got just a default piece here, just glass basically. I've got a glass piece with a shade behind it. And then I've got some balcony pieces too. And we build it up like this. So here's my RailClone object in the scene already. So this is completely from scratch. First thing you want is a generator. So the generator, as we said, is the brain of RailClone. It's where you define the rules. So I'm going to drag in a linear generator. This is a 1D array. And then the first thing I need to do now is to tell it which spline to use. So I'm going to bring in a spline node, wire it to the spline input, and pick a spline from the scene. Now we can start bringing in geometry. So I'm going to bring in a segment. I'm going to pick something from the scene. I'll bring in the start and the end. And I'll wire it to the start and the end input. Now, an interesting thing about this segment is that, as you can see, it goes all the way down to the ground here. Now, I think that's to overlap this floor plate here. So it should probably come down a little bit. No, not come down. There's a slight difference you see in the depth here. So we need to think carefully about how these pivots are arranged. And basically, you can change the way these are aligned in relation to the spline using these alignment settings here. So by default, what it's going to do, it's going to sit on top of the spline at the bottom of its bounding box. It's going to use the middle of its bounding box on the y-axis, which you can see is what it's doing now. And on the x-axis, that depends on the input. And generally speaking, unless you've got a very good reason for doing so, I would leave this one on automatic. So the ones I tend to change are Z and Y. Now in this case, because this spline wraps around the floor plate here, I know this needs to move back to sit behind, so that the back of this sits on the edge of this spline. Now I've set the pivots up for this, I think, to do this already. So yeah, so the pivot is, if we look at it from the top view, roughly in line with the back of this upright. So I can change the alignment on the y-axis to pivot, to push it back. And all of the others should use that same alignment. So we can just now keep adding these things. And in order to save myself having to change that setting every single time, I'm just going to hit Control-C, Control-V to copy and paste that. And let's add this section here, which is evenly, and we'll wire it to the evenly input. So there we have regularly spaced evenly segments. And don't forget, we can come into rules and change the distance here if we want to. Good. Now, let's copy and paste this one more time. And this time we'll add just a standard glass. And wire that to the default input, like so. Let's turn the edges off. So now you can see this is starting to work pretty well. So I've got start and an end, and I've got evenly spaced segments there. In fact, that's probably enough to worry about for the minute. A couple of other things that I would change. It's hard to see in this one, but the way in which this is distributed between the segments is determined by this deform section here. Sorry, in the segment, in a generator, it's determined by the default section here. And by default, it's set to tile. So what happens then is this will just be placed. And then when it hits one of these evenly segments, it gets sliced if it's shorter than the distance between the segments. So basically, it just repeats one after the other, and it gets sliced wherever it hits an evenly or a corner or an end segment. You can also change it to scale. So what that will do is it will scale exactly one of these in between the start and the evenly and the end segment. So you're not getting any slicing going on now, and that's what I want in this case. So this piece here is just always being scaled between these segments. And if I change the evenly distance, you should see this segment here gets scaled. There's always one. You can tell by the number of edge loops there are. Okay, easy enough. So the nice thing now is that we can easily populate a whole building with that. All we need to do is to change the spline. And there we go. I'm going to add this to the corner too. So now I've got them on the corners here. But it's really as easy as that. Once I've set it up on my basic piece of spline, I can easily just populate the whole thing. Of course, I can easily change the distance if I want to change the number of vertical mullions, like so. And you can do a lot more. So this is your basic setup. And this has been created using a generator, which was in here, the brains, the rule set, objects, a segment for geometry, and a spline to define the path. But then we've got a few other nodes. So let's have a quick look at what these are. So I'm going to ignore parameters for now. But what I'm interested in is operators. Operators are essentially something, are nodes that can do something to geometry, can do something to segments. And you have various generators or segments, operators, sorry, that can either randomize or select or create conditional relationships, or you can transform segments and that kind of thing. So as an example, what I'm going to do to start with is, let's say we want to randomly distribute a selection of facade elements, some of which have these shades on them, some of which are just plain glass. So this is the default segment. We'll copy and clone this so that we can pick this extra segment in. And then all we need to do in order to randomize between these two is to add a random node in between the existing default segment and wire them both up. And then you get a random distribution of those shades. Now these could be curtains, they could be blinds, could be something to add a little bit of life to your architectural renders. If that's too many shades, what you can do is change the probability of these. So you're not stuck with a 100% probability for everything. We could have just a few shades, for example, just 20% shades, and you get far fewer of them, like so. Or you could create conditions so that instead of there being shades everywhere, maybe you just want them on these corners. So this is the conditional operator. And without going over all the settings, it allows you to test for certain attributes of the spline or the array and choose geometry accordingly. So I'm going to wire these both in. Do it one at a time. And swap it for the default input. So now you wire them both in and you define what is the true condition. So what do I want the condition to be in order to return the segment that's in the true input? And let's say, for example, that I want it to be that the material ID equals 1. So now I should just have the shades on these corners here. Or maybe if it's 2, I'd have the default segments only on the corners and the shades everywhere else. Excuse me. So there's lots of conditions you can play with here. Like you could change the length of the, you could test for the length of the spline, you can test for the position on the spline or the section. You can test for the type of spline, whether it's a line or a curve, the type of corner, the angle of the corner for the corner inputs, and the segment count as well. So you could have one of these, for example, every other multiple of 2 segments. So you'd have them every other segment, for example. But actually, there's another way of doing that, which is the sequence operator. So the sequence operator allows you to create patterns. So with this, it simply repeats these inputs infinitely. So I've got one and then the other, and it's just going to tile those around the array. You've also got, though, the difference between doing this and using the conditional operator is the sequence operator has counters. So I can say, actually repeat the glass twice and then add a shade. Or glass only once, but repeat the shade twice. So you've got quite a lot of control to create patterns on this, and you can nest these together on the X and you can increment on the Y axis for 2D arrays. This is a 1D array, so that won't work. But for 2D arrays, you can create patterns on the Y axis too. So let's go back to our conditional operator on the corner. Let's keep this as it is, and maybe we'll just set this pattern up to 1-on-1. And then let's say, for example, we wanted on the corners some different geometry, the balconies, for example. So bringing in my conditional node again and wiring it to the corner input. Okay, yeah, so what I've just done, just to précis that, basically I'm using conditional operators to target things that are just on this corner where the material ID on the spline is set to 2. So what it's basically got here is a conditional node here with a different segment, in this case, this shorter upright in the true input and the original upright, which is here, in the false input. And then in the conditional node, in order to tell it which condition we're looking for, I've just turned on material ID and I've said if the material ID is equal to 2, then return what's in the true input, otherwise return what's in the false input. And I've done the same thing for the evenly input and the default input. Okay, so that's sort of roughly where we got to. So that's sort of, you know, more or less it. These are the basic kind of principles. You've got generators that create geometry. You've got objects that bring in items from the scene, which are the splines and segments and surfaces, which we haven't looked at yet. And then you've got operators that do something to that geometry you've brought in, whether you sequence it or create conditional relationships or start manipulating it by mirroring it, randomizing it, and that kind of thing. So there's a whole bunch of stuff you can do there. So let's look at another example, just because this is like the most important thing about RailClone is understanding these principles, really. So here we want to create a kind of facade using these pieces, like a sort of classical terrace. And we can use exactly those same tools to do this. So create a line, which will be the base spline for this. And then we'll create a new RailClone object. And then just start bringing this in. So linear generator, spline to give it a path, and then click to pick the path. Segment. So I've got 1, 2, 3, 4, 5, 6, 7, 8 pieces to bring in here, which is a bit tedious if I have to do it one at a time. So what you can do is actually add multiple segments all at once. Before you do that, you want to set up any parameters that you're going to want to share between all those different segments to save you from doing it again and again. So just like before, I'm going to try setting the Y pivot so that these align correctly. And hopefully I've set this pivot up on all of these, which I have. So that's just to save me doing it multiple times. And now what I can do is right click on this and go to clone multiple. And then I can pick the facade segments from the scene. There are 3 here. And that brings those in. I've conveniently named them something that means something to me. And then you can just start building up just like before. So in here, this is the start here. So this can go in the start input. You can see it starts popping up there. Wire it to the end input. I've got a default segment here, which will just tile the geometry in between. And then I've got a corner input, which I can wire to anywhere where there's going to be a corner. Now, there are no corners on this spline, so you're not seeing that. But if I wire it evenly, you should see an evenly spaced distribution of those. Now, the reason that the windows have now disappeared is that the evenly distance is very small, so they're right up next to one another. If I increase the evenly distance, you'll see the distance between those changes and we get our windows back. something like this. Let's add this one to the corner instead. This one to evenly, yeah, and then this one to the corner. That's what we got. Okay, there we go. So we can see another issue here. Well, two issues really. One, and it's a common misunderstanding about RailClone for users that are familiar with ForestPack. The one thing you'll notice is it hasn't picked up the materials off the source object. And that's a crucial thing about RailClone. That doesn't work like that. For RailClone, you have to manually create your materials in a way that's going to work as though they were one object. So the same one material that's applied to all of these objects will need to be applied to RailClone. It doesn't automatically consolidate them and reassign material IDs itself. You have to do that manually. So I'm just going to take the material that's already assigned to it and attach to there. Okay. And the other thing, if we look down here, is that because this default segment window is tiling, this window is getting sliced where it meets this pillar. It's just getting cut there. Now, we saw a minute ago that we can change the default mode from up here. So clicking on the generator, rules, default. And last time I picked scale, but that's not going to work either. Otherwise, I'm going to get one giant window. So what we can do instead is to change it perhaps to adaptive. And what adaptive mode does is it only adds a new piece of geometry when there's space to do so. And then it will average the size of them all so that they fit perfectly without any getting sliced. So you should see now as I change the distance, the number of windows decreases the smaller it gets, but they're always whole pieces of geometry. Nothing is being sliced. And you have another mode there too, another option up here, which is count mode. And what count mode does is lets you specify exactly how many whole pieces of default geometry are in between the evenly, the corners, and the end. So in this case, it's 2, and no matter the size that I set this evenly distance, you'll always just get 2, and they both get scaled. So in this case, we're going to leave it on adaptive so that the number changes according to the size of these evenly distances here. So another nice thing is that this is still a simple graph, but let's imagine you're in a studio and you have users that really don't understand the graphs at all, or you just don't want to open this graph editor every time you want to make a change to say this evenly distance. It would be far easier if you could just edit it from the modify panel. Well, that's possible, and that's where the parameters come in. So any parameter, numeric parameter that I add to this graph will show up in the parameters rollout here. If I delete it, it'll disappear, you'll see. Add it, and I get a new parameter here. If I give it a name, the name updates down here. You see? And then you can choose what type of number it is. So in this case, I'm going to want a distance, scene units. And then you can wire it to, well, something. There's nothing here. So in order to be able to wire it to something, we need to be able to expose certain properties inside RailClone. We need to be able to expose these properties. And the way we do that is to right-click on any of these nodes and go to export parameters, and it lists all of the parameters that are available to export and be wired to a numeric node. Now in this case, I want to adjust the spacing between these. So I'm going to go to evenly and evenly distance and hit OK. If I wire it to this, I now have control over that value without having the graph open, so I can change it from down here. And that's much easier often when you've got presets set up than opening up the style editor every time and making changes. And with graphs that start to get complicated, you don't really need to understand how the graph works in order to be able to use it. So another important thing is that you're not limited to one generator. It's a common mistake not mistake, but it's a common thing that beginners do that makes their life a little bit difficult, is to try and cram as much as you can into one generator. And actually, you can make your life a lot easier by using multiple generators. So let me turn this one off for a second. This little X in the top right turns this off. Let's say I want a balustrade on the top of this building. I've got some segments here ready for this. So I'm going to go to segment. I'm going to, same thing again, set the y-axis to pivot to make sure they align correctly because I've set the pivots in advance. And I'm going to right click and go to clone multiple. And then this time I'm going to take my roof segments. So I've got balustrade, default, evenly, end. So there's my segments for that. I'm going to want another generator. So I can either clone this one or I can add another one. Not much difference in this case. And use the same spline. So I can use the same spline. So then we just wire this up. So I'm going to go into the start. There's my start segment. And I'm going to the end. Now there's a catch this time because, as you can see, there's a half sort of balustrade on this, which is, if this is the end, it's facing the wrong way. It should be facing inwards. So in order to flip that, we don't need to create new geometry. We can simply use one of these operators. And there's a mirror operator here, which lets you just mirror on the X, Y, or Z axis any geometry. So I can just reuse this like so, mirroring as it is by default on the X axis to flip that around. Then I've got an evenly segment. And again, control this from the evenly distance. And I've got a default. And once again, in order to not have half of a balustrade or baluster, I'm going to set this to adaptive. So that all snaps together really well. I've got a corner too, should I need it. So now I can turn this back on. There's obviously going to be a problem because the balustrade is at the bottom and I'd like it on the top. Easy way to fix that is to go into the generator, and in the general rollout, you've got things that affect all of the segments equally and make general transform, rotations, effects, that kind of thing, to the whole generator, the whole array. In this case, I can use a Z offset value to put this up in the air. On top of the building. Here we go. So I can snap this together. And I could link these together. I'm not going to do it for now, but I could link the height of this to this property so that they match. But let's just keep it simple for the minute. That's fine for the minute. Okay. Good. So now what I'm going to want to do is maybe I want to be able to adjust the distance between these pillars from outside the graph as well. So I'll just do the same thing. Export the parameters, export the evenly distance, and add a new numeric node. Set it to scene units and dial it in down here. I don't know which is which, so let's call it balustrade or some version of that word. There we go. So far, so good. And then you can just keep going. Add as many generators as you need in order to get the job done. So let's just bring in our last segment for the roof, which is just one piece of tileable geometry, and add this here. I've already got the height set up from the previous one. All I need to do this time is I can change the y-axis maybe to top, no, bottom. So that will use the bottom of the bounding box. And then if I need to offset that any further, in the generator settings, I've got y offset values. So you can offset the array on the z-axis and the y-axis. So I can just push this back like so. And I get myself a pretty nifty little facade. Let's just double check the corners because I think they'll need some work. So let's bring a spline over here and just reassign this spline to this angled spline here. Yeah, there's some slightly weird stuff going on in the corners. So this is, let me just turn these off. So basically, what the corner geometry is being bent around the spline here, and I want it to be beveled. So this is all controlled. All the rules for the corners are all controlled from the corner sort of group in the rules tab. And I would want to, in this case, hit bevel corner, which bevels that corner there. And then you can change the offset of this to bring these sides close together, because you can see I've got this weird slice here where there's a pillar in the middle that's being sliced. So if I increase this value, it draws the corner together. That's too much. That seems a bit better. So now I've got my corners set up, and I just want to do that to this one too. So I'll just hit bevel corner, and well, that's okay actually. Okay, so there's a style done using 3 generators. And the nice thing now, again, once you've set this up, okay, that was a little bit of work, but once you've set this up, you can easily actually close this. And I can go into the base objects rollout, and I can simply reassign the splines. So I've got myself a curve building, or a curve building of corners. That's a bit bigger, so it's going to take a little while. And it's a very, very flexible parametric object now, which was relatively easy to create. Are there any questions?
None so far, Paul. I was prompting our attendees to ask away, but not yet. Don't be shy.
No worries. It must be extremely clear.
Absolutely.
Yeah, of course. So I'm going to carry on to that was the linear generator, the one-dimensional array, which has 5 inputs, so it's relatively straightforward. The 2D array is a little bit more advanced. So I'm just going to open up this scene, which will allow us to create a kind of a curtain wall. Just checking my time. Okay, 20 minutes. So I've got some pieces for this curtain wall, and I've had to really think about this like a jigsaw. So this is my bottom row here. I'm going to use it in the top row as well. And this is my kind of default row. And this is an evenly segment, but on the y-axis this time. It all makes sense when we piece it together. So let's go in for RailClone Pro, create a new RailClone object, open the style editor, open the array, and this time let's set the z-axis to pivot, because if we look at the way these are set up, the z-axis in a 2D array is not the way you'd expect it to be. You've got to imagine a 2D array like it's laying down flat on the XY plane of the world. So if you're creating a facade, you have to kind of model the facade on the XY plane as though it's laying flat like this. So I'm going to set Z to pivot. Then I'm going to pick, just so we can see the size, a default piece of geometry from the scene and wire it in. And just to start with, I'm going to not use splines, because actually for both generators it's not necessary. You can do it with just an X and Y size, like so. So I can set the size of this array just numerically. And of course I could export this and make it controllable down here if I wanted to. I'm also going to just apply the material so we can see what's glass and what's metal. Okay. Good, so let's build this up. So we have sort of 12, I think, inputs for this one. So I'm going to pick these one at a time. So this here is going to be our bottom, the corners. And you can see I've got a start top, an end top, a start bottom, and an end bottom. So these are your corners of your 2-dimensional array. So if I go for start bottom, it goes down here. And then I want to go to end bottom, which should end up on the other side at the bottom of the array here. Start top and end top. So these are your 4 corners of your array. Now, actually, this piece of geometry doesn't work in all of those because, as you can see, it's got a little piece where the glass connects to it, which is facing on the outside on this side. So here we can reuse this one segment 3 other times just with a mirror operator. So I will just wire this to the relevant inputs and change the mirrors so that they face the right way. So you can see this is facing inwards now. For the top, start top, I'm going to want to mirror on the y-axis, but not the x. So that's mirrored it so that this little sticky up bit is on top now. And then the last one, which is this side over here, needs to be mirrored on the x and the y-axis. So I can just take this to end top here, x and y. So that's my corners defined. So far, so good. So then we can start building up the top and the bottom too. So I can take this little piece of geometry here and I'll clone it and I'll pick the bottom from the scene and wire this to the bottom input. And there we go. That now tiles across there. If I want it in the top, I haven't got a piece for the top. So I can once again use the mirror trick. I can just take mirror and wire this to the top input there and mirror it on the y-axis. Now, if we just turn on edged faces for a minute, you can see this is tiling along here, and it's not really necessary. I'm creating more segments than I really need to. So what I might do instead is change the default segment mode to scale. So now I've only got one stretched segment. So that's just a little bit more efficient. Good so far. So now we need the left and the right hand side of this array. So let's just move all this down a little bit so we can see what's going on. Take this and clone it. Take the left hand side and wire it unsurprisingly to the start or the left input. So that's in there now. If I want it on the right hand side, well, I haven't got one for the right hand side, but I can mirror it. So I only need to model it once to the end. So I've got it in that side now. And then I could connect my glass back up. So you can see this is kind of a giant window at the moment. And if I change the size, you can see I can control the size of that very easily. But of course, we want some divisions in this too. So that is what X and Y evenly are for. So we've seen X evenly in action, of course. So let me take this piece here, which is our X evenly, and wire it to the X evenly input. So that's all fine. And now we want Y evenly too. So I'll just copy this one more time, and wire it to the Y evenly input. Now, if you see on the side, first of all, let's adjust the distances. So the distances for these are in the same place, but now on the 2D array, you have two of them. You've got an X evenly and a Y evenly input, and you can adjust these sizes independently, obviously. And you've also got a problem on this side here, because this Y evenly segment is cutting through the left and the right, or the start and the end geometry. It's going right to the edges. And really, we want this to carry on up past. So luckily, you can change that. In both of these, there are options to extend to side. On the X evenly, I'll leave it as it is. But on the Y, I want to turn off extend to side. And then I've got a grid that goes in both directions. And of course, you can change the size. And you can change the evenly distances. And we can export all of these too. The other cool thing now, though, is that once I've got this set up, I can switch this to splines. So I could add a spline instead on the x-axis and pick this spline from the scene. And that's going to look a bit wonky, but that's because I need to rotate the array so that it's vertical now. And you can do that. Again, it's the generator. So I'm globally affecting something in the generator. So it's going to be in the general tab. And down here, it says X rotation. If I set this to 90 degrees, it pops up like so. I could also change my evenly segment. I could add my X evenly to the corner maybe. That way I'll get myself a corner on here. So I'm just going to make sure that bevel corners are on. They are. Something going a little bit wonky there. Let's pretend that's not happening. Just for now, I will take that segment out and look into it. Okay. So far I've defined the x-axis of this spline using a spline, and this would allow me to curve this as well. So if I hit smooth here, for example, I can very easily create a curved curtain wall, which still has control for the spacing between these divisions from down here and here, all very nifty. But you can also create a double curved array. So if I was to go into a front viewport here quickly and just draw a spline for the height, and let's add a segment in the middle too. There we go. So I can use that spline to define the height of the array and the path for the height of the array. I just take another spline piece of geometry, spline object, sorry, wire it into the Y-spline input and pick your spline from the scene. If you select this spline, you should be able to edit it and create some interesting double curved geometry. Do whatever you want, really. There's something worth mentioning here too. I'll just mention this quickly. Sometimes if your deformation isn't very smooth, a really useful setting is this curve steps interpolation option here. If you increase this and you've got the edge loops in your geometry, of course, it will deform much more smoothly. It's basically overriding the curve steps settings in the spline itself. But the difference here is that Max limits this to 100 and you can go up as high as you want. So that's a handy little setting. But yeah, so that's the 2D array. The important thing is just to understand those inputs. You've got basically your corners, you've got left, right, top, bottom, default, and then evenly on both axes. So you've got a lot of options there for adding and creating interesting parametric shapes. Are there any questions about that one? Because that is a complicated one.
We do have a question, Paul.
Excellent.
And the question came a couple of minutes ago. So how does the UV layout for the elements work so that I won't have seams? And does it work with substance materials?
It should work with any materials that Max accepts. So no problems there in terms of substance. I've used substance materials successfully. In terms of UVs, that's a good question. If I switch this to materials UV check, let's see if it works. No. Okay. It's not going to show me my UVs for some reason, but that's a 3ds Max thing. I can't take the blame for that one. Okay, so it's a good question. Basically, yes. In fact, since we finished the scene, I can show you quickly in another file. It is possible to get seamless geometry using RailClone. And it works like this. So this is the problem you're encountering, I guess. You've got a section of wall like this, which you can see, because it's being tiled along here, it's got very obvious, very obvious joins where the texture is being sliced, basically. And what RailClone has is the ability to automatically box map across these segments and follow the curvature of the spline at the same time. And it's very easy to enable. You basically just go to the segment, go to deform, and down here it says box mapping. So you hit apply box mapping, and then you can set your size. 5 meters might be too much. There we go. And now, even though the segment ends here somewhere, the mapping continues across those sections. So it's really not much more to it than that. You've got the option to use real world map size if you want, and you can rotate the map if you want to as well. And you can choose which mapping channels you're applying this to. So you've got a whole lot of flexibility there. Yeah, I hope that answers your question.
I think so, but please feel free to give us more feedback. And if you have more questions, Paul is here.
I am.
All right.
So, yeah, just looking at the time, I haven't got long. So I'm going to jump into deform modes quickly. Let's just open this up. So in addition to being able to curve things around geometry, we can also curve stuff vertically. So just to be clear about how this is set up, this is the Z-axis on here. So I'm looking at this from the side. And we can see at the moment that it follows the curvature of this spline, so that the verticals are radiating out perpendicular to the spline. And if I animate the spline, you can see what happens. What you've got is some quite nice controls for how this deformation takes place. So up here, I've got several deformation modes to control that. At the moment, it's adaptive, which is the default, but I can also set it to vertical, which locks the vertical elements so they're upright, no matter how the spline curves, like so. But I've also got stepped too, which doesn't deform it, just keeps everything perfectly upright. Now, where this gets really interesting is that I can combine these. So I can use a vertical mode, but I can step particular parts of this one segment. So I could, for example, and this is really useful for things like stairs and railings and that kind of thing. I could, for example, say, okay, I want it to be vertical. Vertical, and then change the bottom so that it's flat, like so. So I've got a stepped bottom and a vertical top. Or you can do the opposite of that, like so. Or you can give it stepped and I can have a vertical top and a vertical bottom. And what I'm ending up with now is a section which is stepped just in the middle. So by just changing these around, I can either have a vertical middle and a stepped top or bottom, or a stepped middle and a vertical top or bottom. And these are some really powerful little settings. So looking at a real world example of that, we have a railing here. Oops. I have a railing here. And at the moment, it's in adaptive mode, so it's coming out sort of perpendicular to this spline, but we want to change it. So we can easily come in and just change these segments. So all I need to do is change these to vertical, like so. And then what about the handles? Well, we can look at that too. So these are the handles here. So this is the default input. This is the start input. So let's change this to vertical. And let's change the default, which is the handrail itself, to vertical 2. But, you know, it's not matching up. But I can make it match up by changing the mode. So it lines up something like this. Yeah, so you can see it's working there. And the nice thing about that is once you've set it up, it's very easy just to apply the whole thing to an entire staircase. Like so. And even the stairs themselves can be created using this. So here I've got a staircase which is a little bit lethal looking. It's basically a slide. But I can easily just change the geometry that's in here to like stepped mode. And I can create a staircase that's pretty easy to adjust and parametric. And you know, if you wanted closed stairs, then you can get that same sort of effect by having different vertical tops and bottoms and that kind of thing to get a completely closed staircase. And there's a tutorial on our website if you want to have a look at that. Any questions about that?
Nope.
Nope. Good.
Everything is super clear.
Good. What's not clear is where that came from. All right, let's get rid of that. So I'm a little short of time, so I'm going to jump around a little bit. I'm going to go into clipping mode because I think they're really powerful. So I'm going to look at this here, which is a technique for creating roofs automatically. I'm going to start with creating the actual style itself. So here I've got quite a complex roof. The setup is that I have on each plane of this roof, I have splines, but it's one spline object, which contains multiple sub-splines. But it's one spline. And it was created just by extracting these edges automatically from the roof, so nothing fancy there. Here I have a RailClone object, which has I'm just using a single box for now, but this could be a much more sophisticated piece of modeling for a tile. And I've got a clipping area, which is this one here. If I bring in a 2D array, I can automatically fill this area with tiles. So first of all, I'll just wire my tile to the default input. And then I'm going to take this spline, and instead of wiring it to X or Y, I'm going to wire it to the clipping area input. Now, nothing will happen because the clipping area is normally used to cut geometry. But one neat trick is that you can turn on extend XY size to area, and instead it fills the spline area with geometry like this. So another thing I can do, if I wanted to create tiling which alternates so that we've got a kind of, the joints overlap, then we can do that too. We can use the sequence operator we looked at right at the beginning. So I'd wire a sequence to my start and my left and start and end here, and I'll wire a tile into that, and then I want a sort of 150% size tile afterwards. So let's take a transform node, wire that into there, and change the scale on the x-axis to 150. Now it's only at the end, but what I need to do is to change the increment at value to y. That way it tiles, or the pattern goes up on the y-axis of the array instead of the x-axis. And the other thing I need to do, you can see here, we talked about the distribution modes, the default modes earlier. It's set to tile at the moment, which means the last one is being sliced. If we set it to adaptive, you can see it fits together perfectly. Like so. So would it be nice if we could just apply this to the whole roof in one click? Let's try that. It won't work immediately, but we'll get some of the way there. So what happens if I apply it to the whole roof is it has filled every one of those splines, but it doesn't currently know the angle of this roof. It's sort of projected it down from above, looking at this spline from above. What we want it to do is to be able to automatically work out from the spline the orientation and align the array accordingly. And it has a mode to do that. So basically you come into the generator settings again, come into the clipping area settings and change auto align to X to XY. And then it's done more or less all of your roofs, which is pretty nifty. There's also something called hierarchy checking mode. And what that does is it determines, or it gives RailClone a clue when there are overlapping splines, like there are here, as to how it should handle that. So by default, normally if one spline is inside another, it will see that as an additive spline, the outside one, and then a subtractive spline, the inside one. And that's why you end up with little problems like this here. And that's what complete hierarchy checking mode is doing. If I turn this on to none, it treats every spline as though it's completely independent and forgets to check, or doesn't bother to check to see if they're overlapping or not, and you get better results. This one's missing deliberately, by the way, because of the curved roof, so we don't need to worry about that too much. This is another example here. Here I've got an imaginary siding, and I've got splines for the whole building. Once again, I can do the whole building by just clicking the spline for that. And that works pretty well. The whole thing is done. If I open it up, you can see how simple that style is. It's one node connected to a 2D generator. There is another setting here which is worth mentioning, which is hierarchy checking by material ID. Normally this is set to complete, as we saw. Sometimes it's set to none. In this case, we have a window here which is being ignored in complete mode, because it can't quite work out if that spline that's just behind there belongs to this facade, or maybe one that's on the other side here somewhere. And so sometimes you need to give it a little bit of a helping hand. And you can do that by grouping together splines using material ID. So the splines that are on this geometry, if I pick the spline, have the same material ID applied on this side. You can see it's 34, and this outer one here should be 34 as well, which it is. So that's a way of saying to RailClone, hey, these splines, they belong together, so use them as such. And then all you need to do is to just switch hierarchy checking mode instead of none to by material ID, like so. And then that takes care of the whole thing. So you can really quickly populate a whole house using very simple 2D arrays to do that. And then if I may just mention one more thing before we wrap up. I'm just going to jump right to the end because we've looked at some basic examples here, but I wanted to show you very quickly. Actually, I'll just show you very quickly RailClone color. So those of you that are familiar with forest color will know that you can randomize bitmaps and tint things according to just using a kind of a customized texture map. So RailClone has this same material now, this same map type, which is RailClone color. And what you can do is you can either randomize bitmaps using percentages as well to control the probability, or you can randomly sample textures from maps, which is what you're seeing here. So here I've got a swatch of kind of car colors, and I'm wiring into the tint map input slot. I've set the strength to 100% on both. And the interesting thing about this is that the size of the color in that slot basically controls the probability of that color being selected. So in this case, I've got higher probability of white being selected and a lower probability of green and blue being selected, just based on the space that's allocated to them on the bitmap. And what you'll see then when we render this is that it will affect those according to those probabilities. You can also change the blending mode here. So it's set to color by default, but if I set to normal, it takes the whole color like so. So those are basically the same as the blending modes in Photoshop. It's a pretty cool effect. And the other thing I wanted to mention just quickly before I sign off and see if there are any more questions, I wanted to mention that RailClone and Forest Pack are both supported by Unreal Datasmith natively. So this scene, which is 90% RailClone by Bertrand Renoir, we can take this directly into Unreal just by exporting it using Datasmith. This is a slightly old video, so Datasmith looks a little different these days. But you can see that we can just go into the Datasmith format, just save it out. And I haven't converted RailClone in any way. I've just left them as RailClone objects. I haven't converted them to instances in the scene or anything like that. So it exports to Datasmith, slightly sped up. I can then import to Datasmith in Unreal, and the whole thing should come in with its lights and its textures and preserves instancing, crucially. So I'm just accepting these settings. I'm not bringing the cameras in. And eventually we get the same scene that we had in 3ds Max into Unreal directly. And these are all RailClone objects. So it's all more or less preserved the way it was. And like I say, this preserves instancing too. So this was made of a lot of individual rooms, basically, chunks of facade and that kind of thing, all of which were instanced in 3ds Max for efficiency. In Unreal, those are also still instances, which is handy too, because it means if you need to change one, if you need to change them all, sorry, you only need to change one. And here we can see all the instance bits and pieces. So that's a really nifty feature of Datasmith, that it supports both of our plugins. So that hour went very quickly. If you could let me know if you have any questions, that would be lovely.
Yeah, we'll stick around for another few minutes. That was really cool, as you said, very nifty. Very, exciting if you are dealing with rendering and just few clicks. That's all you need. That's pretty, yeah. So yeah, we're here. Don't be shy, ask away. You have great feedback so far. Great job. Thank you. Will be there playback video? Yes, I'm recording this broadcast. It will be posted on YouTube on the Novedge channel, so as early as this afternoon. So come back on YouTube and find it. Novedge.com. The video will be on the product page as well. We're not going to hide it from you. It's going to be blockbusters. And yeah, thank you, Paul. Everybody says very clear to understand. And will there be more videos? Well, hopefully Paul will present more webinars with us. It's always very fun to hang out with you, Paul. So
maybe mention as well that we have a lot of quite detailed tutorials on the website that go over RailClone, a lot of details with a lot of examples of this kind of thing. And I also wanted to mention some of the examples were taken here from 2 guides that we have on the website for those that are new to RailClone. So in our documentation server, docs.i2soft.com, we've got Getting Started with RailClone, which is a pretty ground up foundational kind of introduction to RailClone and the principles that drive it. And then once you've done that and you've finished that and you feel comfortable, we have a more advanced version, Next Steps of RailClone. So these are sort of complete books almost, including exercise files and exercises that you can download if you'd like to really master the plugin.
Perfect. That is really good. Thank you for sharing, Paul. And
Okay.
in the meantime, I'm taking the screen back just so we can wrap it up, but don't leave, because if there's more questions, we're still here for you. Okay. Any news about RailClone 4 and nesting one RailClone into another?
Yes. That's an
Tell.
interesting question. That's like someone who has inside knowledge. RailClone 4 will be released sometime next year, early next year is the aim. And nesting one RailClone object inside of another, or nesting one generator as a segment inside another generator is on the cards. So that I can't make any promises, but that's certainly something we're looking at and should be in RailClone 4, or, you know, if all goes well.
Fingers crossed, and fingers crossed, and hopefully we'll have you back here leading another Novedge webinar for RailClone 4. Great. Okay, so, and this is the page you're seeing now, shows you where you can find RailClone 3 for now on the Novedge.com page. So come find it. We have RailClone, we have a bundle with Force Pack, and we also have 3ds Max. So Novedge is the one-stop shop for all your design needs. And you can find us on all the social media. We're there. And next week we'll have a webinar on Cyborg 3D Mesh to CAD. And we also have recorded today's broadcast, so you can watch it again as early as this afternoon on Vimeo and YouTube. Just search for Novedge. Thank you so much, Paul, for today's presentation. Have a great Halloween, everybody. Bye-bye.
Bye.